Okay, you guys, so I want to look at protein synthesis, or the two steps of protein synthesis: transcription and translation. So what I want you guys to do is, before you start this, you should have a blank sheet of paper. The sub should have given you a blank sheet of white paper so you can follow along. You also need a sheet of paper that looks like this, the RNA codons. Yours isn't highlighted, but you are going to need one of those. So just a reminder, protein synthesis is the basically process by which proteins are made. The first step is transcription, and then the second step is translation. Between these two steps, proteins are going to be made. If you guys remember, proteins consist of many or few amino acids that are linked together that make up a protein. So the first thing that we are going to do is you are going to draw a cell. So, and I have a few different colors. You can have a few different colors if you want. I'm going to start by drawing a cell. Okay. My cell needs a nucleus, since this is where much of stuff that's going to happen is going to go on. So I'm going to make a nucleus, and I'm also going to make my ribosome. I'm going to make my ribosome nice and long down here. So this is my nucleus. This is actually the cytoplasm. And this is my ribosome. Okay. So our first step, transcription, occurs inside of the nucleus. So the first thing that happens is we have our DNA molecule. That looks like this. Go ahead and do one side of our DNA molecule. T, A, C, G, C, A. I want two more. T and T. Almost ran out of room there. Okay. So this is one half of our DNA molecule. So the other half of our DNA molecule should look like this. A, T, G, C, G, T, T, A, and A. Okay, so this is our DNA molecule. It is put together nicely. So what happens is this. Our first enzyme that is involved in this, it's called RNA polymerase, Polymerase. So RNA polymerase comes in, and it is going to break the bonds right here and separate our DNA molecule. So we are literally going to split this DNA molecule in half. I'm going to move one half. Let's move this half over here so we can use it as a template. Okay, so we're going to split this in half, and we are going to use this half of the DNA molecule as a template. So let's see if I can. 3, 6, 7, 9. Okay, T, A, C, G, C, A, T, and T. Okay, so we split our DNA molecule in half, and we are using this half of the DNA molecule as our template. So this is what happens in transcription. So once the DNA molecule has been split in half, messenger RNA comes in and makes a copy. So my messenger RNA, I'm going to do in a different color, is going to come in and is going to make a copy of the DNA molecule. Now, a thing you do have to remember is that there is no thymine. Anytime you have adenine, it matches up with uracil. So thymine, we have adenine, so adenine goes here. Adenine matches up with uracil. Cytosine matches up with guanine, guanine matches up with cytosine, cytosine matches up with guanine, adenine matches up with uracil, uracil, adenine, and adenine. This is messenger RNA. So messenger RNA, now that it's made a copy, so I'm just going to note made copy of DNA. Okay, so messenger RNA, this is the whole idea behind transcription, is that messenger RNA makes a copy of the DNA molecule, and messenger RNA is able to leave the nucleus and move into the ribosome. So, the messenger RNA is going to leave the nucleus and it is going to move into the ribosome. And it is going to be read by the ribosome. So I'm going to transfer my messenger RNA. 5, 6, 7, 8, 9. Okay. So A, U, G, C, G, U, U, A, and A. So my messenger RNA is going to move into the ribosome. Okay. It's going to be read by the ribosome, so we can have amino acids come into the ribosome and proteins to be made. This messenger RNA is read by the ribosome per every 3 letters. So this 3 letters, and then these 3 letters, and then these 3 letters. These are called codons. So every 3 letter, okay, that is read is considered a codon. So codon 1, codon 2, codon 3. So the ribosome reads it and sends a message out to the transfer RNA, which is floating around in the cytoplasm. The transfer RNA has the complementary or matching letters, okay, for each of these codons. And each transfer RNA carries an amino acid. So it's going to look something like this. We're going to draw our transfer RNA. Our transfer RNA comes in what we call anticodons, so every 3 letters for our transfer RNA. So my first one, I'll do it a different color. I've got 1 piece of RNA, transfer RNA, UAC, and that is going to carry an amino acid called methionine. And I would have another piece of transfer RNA, which carries another amino acid, GCA, and that is serine. And we would have another transfer RNA, and this codes to stop. We'll make that a triangle, and that's AUU. So each one of these 3 letters on my transfer RNA, I'm going to label this tRNA, tRNA, and tRNA. So each one of these transfer RNA has the matching code for each of the codons here. So each of these are considered anticodons. Oops, let me try it again. So each of these 3 letters are anticodons. They are going to have the complementary letters that match our codons. So they are going to move into the ribosome, and they are going to match up with their codons. So my anticodon, again, these are all transfer RNA, UAC, and this carries methionine. This one comes in and it matches up. Guanine, cytosine, and adenine, and that has serine. And the last one comes on in and matches up, AUU, and that amino acid tells me, or tells the ribosome to stop. So then what happens is our amino acids, so again, these are amino acids. Our amino acids are going to be linked together by peptide bonds. And as soon as the ribosome reads the stop, that means our protein is made. So our protein is going to look like this. We're going to have methionine attached to serine, attached to a stop codon. So this turns out to be our protein. And this part inside of the nucleus, so the transfer RNA, the ribosome reading the codons and having these different amino acids come in, that is called translation. So I'm going to kind of split my paper down the middle, and I'm going to label this side transcription, and I'm going to label this side translation. Okay, so when it comes to figuring out what amino acids these anticodons carry, okay, what happens is the ribosome reads these letters and it tells the transfer RNA what amino acid to bring in. Now we have something that helps us to determine which combination of codons will give us certain amino acids, or will code for certain amino acids. And that is called the genetic code, or universal genetic code, and that's what this is right here. So let me show you how to use this. That will give you an idea of how I ended up with these three different amino acids. All proteins are going to start with some sort of start codon. In this case, methionine is a start codon. It starts making a protein, and then it's going to end with some sort of stop codon. So the ribosome knows, hey, it's time to stop making the protein. It's done. Okay, so the ribosome reads the codons, okay, down here. So in groups of 3, AUG, CGU, UAA. So I'm going to start with the AUG. I'm going to go to my universal genetic code, and this column right here, this is the first letter. Right here, this is going to be your second letter, and this is going to be your third letter. So I have AUG, so A, here's my second letter, U, and I come over here, still in the A section, and G. So A, U, G will give me methionine. That's my start codon. So my second codon is CGU. So I'm going to come over here, and I'm going to go C. I'm going to come over to column G and find U. Let me see if I got that right. C, G, and U. Oh, I got the wrong amino acid on there. That's arginine. So this guy should be arginine. Okay. And our last one, UAA. So UAA is going to be my stop codon. And that's how I get this stop right here. So the ribosome reads these codons, and if we know what these codons are, we know what amino acids, okay, our anticodons are going to bring in, or our transfer RNA is going to bring in. And that's translation and that's transcription. Transcription is the copying of the DNA material by messenger RNA, The messenger RNA then moves into the ribosomes. The ribosome reads each codon, so every 3 letters, and sends out a message in the cytoplasm to have our transfer RNA, which are in anticodons, to pick up these specific amino acids and bring them into the ribosome. And those transfer RNA, the anticodons match up with the codons. They get close together. Peptide bonds bond them together, and a protein is made. And that is protein synthesis right there. You should have copied all that information down. You can also write any of this video lecture into your notebook as text. If you want to translate what I've said into notes, you are more than welcome to do that. Hope you guys are doing well and being good for the sub, and I will see you soon.